Hello, class. Welcome to the next part of the lesson. So if you are in the period 4 class, this is section 6.4. If you're in period 3.8 or period 6, then it's section 4.4. What we're going to talk about next are the SIGNs of the trig functions based on the quadrant. So as you know, the reason I'm going to start spelling SIGNs when I'm talking about positive and negative is because we have a homonym here. The word sine means two different things to us at this point. So the word sine could be the trig function, SINE, or it could be SIGN, where we're talking about positives or negatives. So again, it will seem weird at first, but you'll get used to it. You might even find that you do it if you're talking about the material. So just to review real quick, the definitions that we learned are that for a point xy on theta and r as the square root of x squared plus y squared, r is always positive. We know that the sine of theta's new definition is y over r. SOHCAHTOA is still good, guys. It's going to come back. But for now, we're going to use these new, more powerful definitions. Eventually, though, we'll relate these definitions to the SOHCAHTOA definitions. So sine is y over r, cosine is x over r, and tangent is y over x. The reciprocal of sine is still cosecant. So that's nice. That didn't change. The reciprocal of secant, cosine is still secant, and the reciprocal of tangent is still cotangent. And remember, these work for any angle, not just acute angles. So that's why they're more powerful. All right. Now, this is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. We typically use Roman numerals to denote the quadrants. And what we want to do is we want to take a look at each quadrant and determine which trig functions would be positive and which trig functions would be negative. So in quadrant 1, think about any point in quadrant 1. This point, this point, this point, this point, any point in quadrant 1. The x-coordinate is going to be positive and the y-coordinate is going to be positive. R is always positive. So if we think about this, for the trig function sine, since sine is y over r, that would be a positive over a positive. That's positive. And the trig function cosine is x over r. That's going to be positive. And tangent's y over x. That's positive. They're all positive. Because remember, if sine's positive, it's reciprocal cosecant's positive. And if cosine's positive, it's reciprocal secant is positive. And if tangent's positive, its reciprocal cotangent is also positive. So the deal here in quadrant 1 is all 6 are positive. All 6 of the trig functions are going to be positive in that quadrant. That's not going to be the case in quadrant 2. In quadrant 2, think about any point in quadrant 2. This point, 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 this point. Any point in quadrant 2 is to the left. So x will be negative, and any point in quadrant 2 is up, so y will be positive, and r is always positive, because to calculate r, we're going to square x, square y, and add them. That's going to be a positive plus a positive. It's still positive. And then we take the square root, it's still positive. Okay, so let's take a look. In quadrant 2, if y is positive and r is positive, then sine is going to be positive. Okay, and if sine's positive, so is cosecant. All right, in quadrant 2, if we have cosine, cosine's x over r. That's a negative over a positive, so cosine is going to be negative, and it's reciprocal. That's going to be negative as well, because if cosine's negative, then secant's negative also, because they're made up of the same pieces, even though they're flipped. And then in quadrant 2, tangent, since tangent's definition is y over x, a positive over a negative is going to be positive. A positive over a negative is going to be a negative. So in quadrant 2, sine and cosecant are positive, and the other 4 are negative. Okay, so sine and cosecant are positive, and the other 4 are negative. So sine and its reciprocal are positive, and the other 4 are negative. Okay, moving on to the next quadrant, quadrant 3. In quadrant 3, think about any point in quadrant 3. Since all the points in quadrant 3 are to the left, x is negative, and down, y is negative, but r is always positive. So let's figure out who's positive and who's negative here. The new definition of sine is y over r. So y over r would be a negative over a positive, which is negative. So sine is negative, and so is its reciprocal cosecant. How about cosine? Cosine's definition is x over r. That's going to be a negative over a positive. Cosine also negative, and its reciprocal secant. And how about tangent? Tangent's y over x for the new definition. So if you put y over x, that's a negative over negative. Tangent is going to be positive. And if tangent's positive, so is its reciprocal cotangent, because x over y would be a negative over a negative, which makes positive as well. So tangent and cotangent are positive in quadrant 3, and the other 4 are negative. Okay. And then let's repeat the process for quadrant 4. So in quadrant 4, if you take any point in quadrant 4, you're to the right of the origin, so x is positive, but you're down below the x-axis, so y is negative, and r is always positive. Go ahead and figure out who's positive here. Okay, its cosine and its reciprocal are going to be positive. I wrote cosine and reciprocal. I guess I could have written cosine and secant are positive, and the other 4 are negative. Okay, so cosine and its reciprocal are positive, and the other 4 are negative. Cosine's positive because we have x over r, would make a positive over positive. Sine would be negative because it's y over r, and tangent would be negative because it's y over x. Okay, so that's the deal. In quadrant 1, all 6 trig functions are positive. In quadrant 2, its sine and its reciprocal are positive. Everybody else is negative. In quadrant 3, tangent and its reciprocal are positive. Everyone else is negative. And in quadrant 4, cosine and its reciprocal are positive. Everyone else is negative. Now, it doesn't seem as important as it is. We're going to end up using those facts on a regular basis. So what we want is an easy way to remember that without having to figure out the SIGNs for X, Y, and R every single time. So what we have is a mnemonic device. So the mnemonic device is, this is how you spell mnemonic, believe it or not, and it's a memory aid. Okay, so mnemonic device is all students take calculus. Okay, it may not be a true statement, but it's going to help us remember. So when we go to write this, all students take calculus, we take the first letter of each of these, start in quadrant 1 and go around in the counterclockwise direction. So go to quadrant 1, 2, 3, 4. All students take calculus. Okay, so that's how you remember, and what it really stands for is in quadrant 1, all 6 are positive. In quadrant 2, sine, that stands for sine, and its reciprocal are positive. In quadrant 3, the T stands for tangent. Tangent and its reciprocal are positive. Everybody else is negative. And in quadrant 4, C stands for cosine, not cotangent, not cosecant. Cosine and its reciprocal are positive. Everyone else is negative. So the way you remember is all students take calculus, and here's what it stands for. Okay, so if you printed the worksheet, you're all set. Otherwise, you want to write this down, and you might just write it here. All 6 positive, sine and reciprocal positive. That'd be a quicker way to write that if you have to write all that down. Sine and its reciprocal are positive. Everyone else is negative. T stands for tangent and its reciprocal are positive. I should use the word and there so you don't think that's another positive. Sine and reciprocal are positive. Tangent and reciprocal are positive. And here stands for cosine and its reciprocal are positive. Everyone else is negative. Okay, we're going to be using this fact on a daily basis, but what I'd like to do is get a little practice with this. And here's how we're going to practice. Okay, so practicing with the SIGNs based on the quadrant. Use the given information to find out where the terminal side of theta might lie. So here's our first one. Cosine theta greater than 0 and tan theta less than 0. First, let's translate this. This means cosine is positive. That's what greater than 0 means. The other fact we have is tan theta less than 0. That means tangent is negative. So those are the 2 facts that we have. Let's use our new mnemonic device. All students take calculus. And what we do is a process of elimination. So take the first fact. The first fact is that cosine is positive. Okay, ignore the tangent fact for a minute. Cosine being positive. Is quadrant 1 still in play? Yeah, because they're all positive there. If cosine's positive, is there any chance we're in quadrant 2? No, because only sine and cosecant are positive. Cosine would be negative. I can eliminate that quadrant as a possibility. Based on the fact that cosine is positive, I'm ignoring everything else right now. If cosine's positive, could we be in quadrant 3? No, because only tangent and cotangent are positive. And based on the fact that cosine is positive, could we be in quadrant 4? Yeah, because in quadrant 4, cosine's positive, and so is its reciprocal secant. Okay, so based on this fact, we've narrowed it down to quadrants 1 and 4. Now, with the quadrants we have remaining, use your other fact. If tangent is negative, could we be in quadrant 1? No, because in quadrant 1, they're all positive. Let's check quadrant 4. Is tangent negative in quadrant 4? Yes, because only cosine and secant are positive. So what we have is quadrant 4 for our answer. And it's a process of elimination. Some of you will want to write down ASTC every single time and cross out the quadrants that don't work until you find what's left. Some of you will do this in your head or just write this once on your paper. Any variation of that is okay. But as beginners, I would suggest you write it down. And you might even want to write down for yourself. Use one fact at a time and cross out any quadrant that doesn't work. Okay, so if you want to write down like steps, those would be the steps. Use one quadrant at a time and cross out any quadrant that doesn't work. Okay, let's make our way over here to cosecant theta greater than 0. So this time I only gave you one fact. Here I gave you two facts. This time I gave you one fact. This says that cosecant is positive. That's what greater than 0 means. So cosecant's positive. Unfortunately, with all students take calculus, none of these stand for cosecant. That C doesn't stand for cosecant, it stands for cosine. Okay? So what we want to do is we want to use the fact that the reciprocals have the same SIGN. So if cosecant is positive, then its reciprocal sine is also positive. So if sine has to be positive, could we be in quadrant 1? Yeah, because in quadrant 1, all 6 are positive. So that's still in play. That's a possibility. If sine has to be positive, could we be in quadrant 2? Sure, because in quadrant 2, sine and its reciprocal are positive. The other 4 would be negative. Could we be quadrant 3 if sine's positive? No way. Can't be quadrant 3 because only tangent and its reciprocal are positive there. And how about quadrant 4? That's out as well because only cosine and its reciprocal secant are positive there. Sine would be negative. So what we have with one fact is we have two possible quadrants. We could be in quadrant 1 or quadrant 2. We don't have enough to narrow it down to one single quadrant, but that's where theta might live. That's where the terminal side of theta might be. It could be in quadrant 1 or quadrant 2 if sine's positive and cosecant's positive. All right? So if you have two facts, you'll get it down to one quadrant. If you only have one fact, you'll have two quadrants possible. Let's go ahead and try these. Okay, so go ahead and try number 3, cosine theta less than 0. And number 4 is sine theta less than 0 and cotangent theta greater than 0. All right, for number 3, the answers are quadrant 2 or quadrant 3. And for number 4, if sine is negative and cotangent is positive, then you must be in quadrant 3. All right, let's go over these. So for number 3, if cosine is negative, if we do a little all students take calculus here, for cosine to be negative, quadrant 1 is out because quadrant 1, they'd all be positive. Quadrant 2 is in play because sine would be positive and its reciprocal, cosecant, would be positive, but cosine would be negative there. For quadrant 3, only tangent and cotangent are positive. So that's a possibility because we want cosine negative. Quadrant 4 is out because cosine would have been positive there. So looking for where cosine's negative, we have to cross out 1 and 4 because cosine would be positive, but 2 and 3 would be possibilities because that's where cosine would be negative. And then for this one over here, we do a little all students take calculus. The first fact is that sine is negative. Let's use that fact first. If sine's negative, we can't be in 1 because that would be positive there. Can't be in 2 because sine would be positive there. We could be in 3 or 4 because sine is negative in each of those. The second fact is that cotangent is greater than 0. Greater than 0 means positive. Now, none of these letters stand for cotangent. So what we want to do is use the reciprocal. If cotangent's positive, then tangent is positive. So of the two remaining choices, where's tangent positive? That's here. We can't be in quadrant 4 because in quadrant 4, tangent would have been negative and tangent's supposed to be positive. So quadrant 3 is your answer there. All right. So hopefully that made sense, and we'll be able to continue on and use these facts and start to put it together in our next lesson. Thanks for watching. Bye-bye.